The first thing that I wanted to talk about really was why you might want to consider applying to Cambridge. Obviously, if you're already on this webinar, then you're going to be aiming quite high, thinking of going for these very top academic, selective, competitive universities. So, why particularly consider Cambridge? Well, we offer a world-class education. We're consistently up there in terms of the top 3 universities in the world. We provide supportive environment, not only in terms of academics, being able to sort of push yourself beyond the boundaries of normal things that you'd be learning in general, but also in terms of pastoral support, because we are able to provide access to things like pastoral tutors who are there to look after your well-being, as well as you having a director of studies who's assigned for your academic needs. If you have anything at all that you need to bring up to your academic tutor, you'll be able to do that. And equally with your pastoral tutor, you'll be able to discuss any kind of welfare concerns that you might have. There's also the welfare teams at different colleges, which are able to make sure that whatever issue you have, they will be able to help you sort it so that you can have a very fulfilling experience at Cambridge. And also, just to note that Cambridge itself is one of the top 10 UK universities that are most often targeted by Britain's leading graduate employers. And obviously, a very nice aesthetic photo of Cambridge there. So, for those of you who have visited Cambridge before, you might be familiar with it as quite a old, quite quaint little city. If you haven't had the chance to visit us, I hope you'll come down for the July open days because it really is lovely to see Cambridge in the summer. But it's part of the charm of the place. It has so much history. We've been around since the 13th century, essentially, and we've been the home to so many amazing discoveries, especially in the natural biological sciences, which I'm sure you will be aware about. I think my personal favourite is the discovery of DNA. So a little bit more then about the collegiate side to this university, because you may have already be quite familiar with this, or you may not. But essentially, what does it mean to say that Cambridge has colleges? Because it is slightly different to other universities in the UK that might not have this system. So Oxford and Cambridge are collegiate universities, which means essentially that they have these mini campus communities, a bit like schoolhouses is probably the best way to think about them, that all make up the university. So Cambridge has about 31 different colleges that will play a really, really big role in terms of providing you a place to live, eat, sleep, socialize a lot of the time. You will be able to socialize with people from other colleges as well, but your college will often be that main community that you belong to whilst you're at Cambridge. And another kind of good way of thinking about it is essentially it is a bit like a Harry Potter house in the sense that you all belong to your own version of the university, of the college, but you also are under the same umbrella of Cambridge. A college is responsible for admitting students, providing academic pastoral care, accommodation, dining, recreation, organising small group teaching, facilities for academic study, whilst the university is more responsible for determining course content, organising lectures, seminars, practicals, things to do with how you're taught academically, also giving you your exams, and then finally awarding you your degree. So essentially, whatever college you go to and whatever degree you study, you will receive that degree from Cambridge University. What about Homerton? Well, we are currently giving this talk from Homerton College, which is the oldest not the oldest, the newest Cambridge College, which was officially given full collegiate status in 2010. But we do have elements that go right back to the 1800s, so we combine old and new. We have the largest and most diverse college community, taking students in all subjects that are offered by Cambridge. We are committed to making a positive impact on the world, which can be sort of shown not only through the great things that our alumni go on to do, but also a world leading and quite unique development program for our students called Changemakers. And I've included some lovely photos of the college there. So hopefully you'd like to come and visit us at some point in July, or specifically for the open days. A little bit more about us in terms of what facilities we are able to offer. So we're very close to the train station. We provide really good links to across the country to London. We also have over 25 acres of beautiful gardens and grounds and really, really good facilities. So we have a gym, which is free if you're a student, sports grounds, a 24-hour library, cafe, thriving student bar, and also a student union. We are also providing some of the cheapest student accommodation in Cambridge. So it's all been either rebuilt or refurbished within the last 10 years. And it now boasts of more ensuite rooms with internet access than any other college in Cambridge. So it's both the cheapest and ensuite. And we've also pictured on the screen is our principal, Lord Simon Woolley. He is the first black man to be made a principal of a Oxbridge college, which kind of shows you the forward-thinking, dynamic environment that Homerton is able to inhabit. We are also able to provide a lot of financial support at Homerton through different grants and scholarships to support your studies, different kinds of grants for music and travel as well, which goes beyond just things to do with your academics, but could be related to your academics. So, say if you were needing to do a field trip for biology, actually, usually there'll be grants out there university wide, but also sometimes college wide to support that. There's student representation awards, internship grants, a college hardship fund, and also support for young carers and care experienced students. I've realised this is a very quick run through, but essentially, I just want to remind you as well of the application process to Cambridge, because hopefully you'll already be thinking about it if you've joined this webinar, but you do need to be aware that we have much earlier deadlines than other universities. So Oxford and Cambridge both will have you needing to send off your UCAS application by the 15th of October. So by that time, you'll need to have chosen your course, chosen a college that you want to apply to, or also whether or not you're going to make an open application, which is essentially where you give a computer the ability to just randomly assign you a college. Then you need to make sure you've checked your admission test arrangements and send off your UCAS application by the 15th of October. And just make sure that when you're registering for your entrance test that you have actually registered, because unfortunately we don't handle the registration element to it. So if you come and turn up to a test center and they don't have a record of you and they turn you away, we can't do anything about that. We will just have to cut your application. So please make sure that you sign up in time and that you sign up to a test center that's hopefully near to you, and do it as early as possible because the places fill up so quickly. Then you'll need to complete any additional forms for us, which might include the My Cambridge application form. More information on that will be on the Cambridge website, but also loads of different webinars that are running. You'll need to submit written work and or take the admissions assessment that you need to do, which Paul will be talking about in a bit as well. And then finally, if you are selected for interview, this will typically happen in December and you'll find out the decision in January. So this is a very, very quick run through of the Cambridge application process, but hopefully I can now pass over to Paul.
My name is Dr. Paul Elliott, or Paul, and I'm the Director of Studies in Biology here at Homerton. And so my job as Director of Studies is to look after all of the biologists that come to see us, that come to work here. I get to know them sort of very well. I end up writing references for them for their entire lives, basically. We do lots of pizza evenings. We've got sort of one coming up next week. We have dinners. I take them bowling. But most importantly, my job is to oversee the progress of students when they're doing biology at Cambridge. So I meet students often every couple of weeks to talk about how they're doing, about what interests they have, about where they want to go, to advise them on careers, to advise them on internships, basically to help them in anything academic that they need help with. And that includes advising them on what modules that they might want to study. So in this presentation, what I'm going to do is take you through biological natural sciences at Cambridge. So I'll take you through the course, talk a little bit about it at Homerton, and then I'm going to talk about what we look for in students. And in particular, I'm going to take you through a few interview questions that I've asked in the past, including the question I asked last year. So hopefully it'll be of use because you'll get an insight into the types of question that we ask during interviews. Okay. So firstly, natural science at Cambridge. It's slightly unusual. It's a very broad course whereby we teach basically science, and it's taught across 16 departments and includes both physical, biological, and chemical sciences. So there are loads of different modules. And basically, as a scientist at Cambridge, you can pick from a variety of these different modules. The course starts out with quite a broad first year. So you get to taste lots of different types of science. already 4 key types of science, but you can pick those from a variety of choices. And as you go through the course, you get more and more specialized. So you start to focus more and more on a particular topic. So for instance, I specialized in zoology in my undergraduate here at Cambridge, but you could equally choose to specialize in plant sciences or pathology or pharmacology, or even there are some psychological elements, or you could decide that you want to go down a chemistry route. Basically, there are loads of different options for your third year where you become a specialist in a subject. In the first few years, you do broad, so you pick from a variety, and then you specialize later on. And that's why our course is quite tough, because you get the breadth of understanding in the first few years, but then you become specialized later on. So you go into the same degree of depth as you would do on another course. Now, we do this because it enables our scientists to experience lots of different areas of science. So you'll be a true interdisciplinary scientist when you come here. And you get to discover lots of connections between different sciences, things that you might not get at other universities. So for instance, as part of my doctorate, I actually did part chemical engineering and part zoology. And that was partly because of the range of different topics that I'd encountered during my undergraduate degree. It's also a method that gives you the opportunity to postpone your decision to specialize until you're absolutely sure about the direction you want to take. So if you're not quite sure on what you want to do, you can leave it until later on, until you decide to specialize. Whereas at other universities, you might start a course where you have to specialize immediately. So as I said, it's a quite an unusual course that gives you breadth as well as depth. And it's the combination of the two things that makes it, quite tough, but a really, really valuable degree. To give you an idea of the subjects that you can take on natural sciences, I've got the first year subjects in front of you. Now, I should say, as a small proviso, these are the first year subjects for the incoming year, so for the 2005 intake. If you are thinking about applying, the subjects may be slightly tweaked and have slightly different names in your year. And that's because they're doing a slight review of the course to try and create clearer pathways through. So if you wanted to, for instance, focus more on biomed, some of the titles are changing just so you can see a clearer route through. But fundamentally, the broad subjects will remain the same, but there may be a few tweaks to some of the subjects that are taught on each one. Not big ones, but like you might have a few lectures extra on plants and maybe a few less lectures on fungi or something. So these are our courses for 2005 entry. For 2006, it may be slightly different. But you can see, broadly, you get to choose between cell biology, chemistry, earth sciences, evolution, material science, physics, and physiology. And you choose 3 of those in your first year. And you have to choose 1 mathematical subject. And again, the names of these subjects may change, but fundamentally, you'll be able to choose biological maths or a kind of more physical maths instead. So that's in your first year. You do 4 modules. Each module will have 3 hours of lectures a week and probably a supervision. And you will have a practical which might take up an afternoon. Okay, so that's quite a lot of teaching. It's good value for money on our natural sciences course. In the second year, you can see that the number of subjects you can choose broadens, and you choose 3 of these subjects to do, which means you have slightly fewer lectures, which gives you more time to go into a bit more depth about some of them. So you might pick 3, you might pick ecology, evolution and conservation, you might pick pharmacology and psychology as well. So it's up to you, but any 3. There are just a few limitations in terms of when these lectures run, but for the most part, you can choose a broad range. Most students, of course, choose to go down a more chemical side, a physical route, or a more biology route. But increasingly, biologists are taking subjects like computational biology, more numerical courses as they progress. And then in the final year, I mentioned there are lots of specific choices that you can make. So you've got things like astrophysics, biochemistry, chemistry, earth sciences, genetics, material science, pathology, physics, pharmacology. An interesting one is history and philosophy of science, where if you want to sort of learn about the history of science and write more essays, that's really good. But there's a broad range of topics. And if you really are still unsure about the course you want to do, then you could choose biological and biomedical sciences. And that basically means that you pick a major subject from the list here, but you also get to do some minor subjects. So you get to do some other modules, which sometimes including things like management or um, basically there's a range of different additional skills that you can learn as part of these modules. That's if you're still unsure, but for the most part in your third year, you'll pick one of these subjects, you'll become a member of that department, you'll often do a project with a really high level supervisor in that department, and you'll just become fully immersed in a particular topic there. So that's your third year. And of course, some subjects can go on to do a fourth year as well. So for instance, if you're interested in biochemistry, that's a possibility, or chemistry. But that most of the fourth years are more on the physical side, I'll be honest. Quite a popular one for the biologist is called systems biology, which encompasses lots of different biological topics together. So at Cambridge, as Sabrina mentioned when I was getting all sorted out earlier, that you come to a college and your college looks after you, but fundamentally, whichever college you go to, you get the same course. And for a scientist, that consists largely of lectures in the mornings, run in the departments in the center of town. You also have practicals in the afternoon with some state-of-the-art laboratories where you'll get together with other colleges and do lots of amazing experiments. There'll be lots of time for independent study as well and work in the library, often doing practical papers or writing essays. And also a key part of our course are the supervisions, where every week you sit down with an academic like myself and you discuss the course in depth. And this is the key benefit of the Cambridge system. You get to talk about your subjects, you get to ask questions, you get to probe the intricacies of the subject in a lot of depth. And actually, one of the reasons why when I came on earlier, I was so flustered is I was teaching evolution right up until this webinar in my office just a minute ago. So I was teaching two students, but in this case, about the history of domestication in animals and also global change, so how humans are changing the world. And it was just three students, and we're chatting about the lectures and about, I was clarifying things that they don't understand. So it's quite a busy week. So if you look at a timetable, you a fair amount of time spent in labs like this, in lecture theatres. We also do some amazing field courses. One of the benefits of doing biology is that there are often options for you to do amazing field courses as well. And so we have field courses that run to places like Portugal. For plant sciences, we have ones in Wales and in Devon for evolution. We have in the third year in zoology, you can get to go to Borneo or Panama if that's what you want to do. So there are these incredible field courses, actually quite cheap field courses to go on. You barely have to pay anything because they're part of your course. But you get to travel and to really immerse yourself, if that's what you like doing, for earth sciences, plant sciences, or zoology. But mostly a week's timetable looks like this. This is a second year timetable, and you can see that they have 9 hours of lectures a week. And you'll notice now that they have lectures on a Saturday. There is discussion at the moment in the university about whether we are going to continue this, but I can't say anything more. There's some debate, but it could well be that by the time you're applying, it may be that they decided not to do that. We don't know for sure at the moment. But you can see there's also practicals in the afternoons. This student is doing basically molecular biology, they're doing plant sciences, and they're doing neurobiology. And you can see practicals in the afternoon. On top of that, there are supervisions in the light blue, where you sit down with academics. There'll be time for you to do your own work in the afternoons. And if you're really organized, there'll be time to do lots of other things as well. This, I should say, is a highly idealized timetable where students finish a lecture and go and do some work, rather than finish a lecture and go and have a coffee and talk to their friends. So this is perhaps not the norm. I think a number of students would go and socialize with their friends in some of the gaps and then work later on. But you should be able to do the degree in a normal working week if you are organized. Okay. this student has got a very strange plan. They're sort of doing calligraphy. I don't know where that came from. But that's a rough plan for the week. Now, in terms of what we look for, this is probably what you're all interested in terms of what we look for in our applicants. So I'm an admissions tutor at Cambridge. It's my job to oversee the admissions to my own college. So I oversee admissions to the biological natural sciences course. I oversee the physical natural sciences, mathematics, economics, engineering, psychology, basically most of the sciences. So hopefully I can give you some insights into what we look for. So this is a broad summary of the process. And the first thing to do is choose your course. And it's really important that you choose the right course. So as I've mentioned, biological natural sciences is a really broad course, but also goes into depth. It may be that you might prefer a focus course where you get straight into the content, of the subject you want to do, like an ecology course straight away. But it's really important that you choose your course because you need to be happy on your course. You're going to be fully immersed in your course, and you need to make sure that the course is the right one for you. So have a look online at our modules that we do. Have a look at what the content is. Remember that they may be tweaked, but they will broadly be the same for if you apply. But it'll give you an idea of the range of topics that we cover, and you can compare that to other universities to see if that's the kind of if our course is the one you might prefer. Then it's a case of choosing a college if you want to, or you can make an open application where your application is sent to a college that has need of students in a particular subject. But this is probably the least important part of the application because most colleges, well, all colleges have the same level of support. They have directors of studies like myself, they have tutors, they have great well-being teams, they have incredible grounds, the kind of Harry Potter style dining halls, they have the social environments. And remember, whatever college you go to, you'll get the same fundamental course. Now, that being said, every college will always tell you that they are the best college. And I can totally say, I'd love it if you could apply to Homerton. We are always looking for great applicants. We're generally viewed as being a very friendly and a very sort of not relaxed college, but we sort of, we place a lot of importance on students developing as they want to develop in terms of trying to get where they want to go in life and thinking about how they can change the world. So yes, we focus a lot on academic performance, but a lot of the time I'm also talking to students about, well, what do you want to do afterwards? Let's get you to that point. Tell me what you want to do, and I'll help you get to that position after you leave. And many of our graduates from Homerton go straight into research or into amazing jobs where they get paid far more than I will ever be paid. So we'd love you to apply for us, but it really is the least important part of the application. Then you need to register for the admissions assessment by the 29th of September. This is really important. So Natural Sciences has an admissions assessment, which I'll talk about later. And it's really worth noting that the deadline for applying for that assessment is before the UCAS deadline. So remember that. You have to apply for the assessment before the UCAS deadline. That's really, really important. You can't just wait for the UCAS deadline. You have to do it before. Now, you might ask why that is, and it's not ideal. It's a long story, which I won't bore you with, but unfortunately, we're kind of lumbered with that. It's partly due to the fact that the processing of the assessments take a while and we have to get them back to us before we can decide whether we invite you to interview. So it's about timescales, but you must register for the assessment. There is a fee for that, but there are bursaries available, which a number of students will be eligible for the assessments. Then you make your UCAS application on the 15th of October. It's early for Cambridge and Oxford, and you can only apply to one of us, Cambridge or Oxford, the other place. Then we send you we get you to fill in an online form by the 22nd, which enables you to tell us why you want to apply to us, particularly to Cambridge, and that way you can focus on our course. Whereas in your general UCAS application, you're going to be applying to your other universities, so you won't be mentioning that Cambridge is great, but you can mention that in the supplementary form we send later on. Then this year, actually this is all out of order, the admissions assessment is on the 9th or 10th of October. And then we interview in December and we make a decision by January. Now, it seems like quite an arduous process, but the whole point of this is so that we can collect as much information about you as possible so that we can look at you as an individual to decide which students we think will thrive on our course. And another way to think about it is there's lots of different stages because it gives you lots of different ways to shine that you can show us what you can do. Okay. And I'll talk about a few more of those things just shortly. So what do we look for in our applicants? Now, the first thing is we do need you to be achieving or be predicted to achieve qualifications at the level that we will eventually make an offer on. So our standard offer, which we make for the vast majority of students, is A star, A star, A at A level, or 776 at higher level, and 42 points in the IB. Now that's tough. It's hard. We know it's tough. But the majority of applicants that we have will be predicted at those levels and will go on to achieve those grades. If you're not predicted those levels, if you're close and there've been extenuating circumstances, then you can tell us. And we are human. We'll look at those. But we do need to see that you would be predicted at those levels because all the evidence says that based on what we have from the past, that students who are predicted those levels will do fine. If students have had difficult situations, then again we can account for those. But we do kind of need you to be predicted in that area. But tell us if you're not and why. Okay. You do need to be doing. We do generally advise that you have maths as well. We're looking for maths and 2 science subjects. That's because our courses are becoming increasingly mathematical, and maths is really important in biology as well for all of the analysis you do. There's incredible modeling that you can do in terms of modeling populations, and maths is really critical. And so the vast majority of our applicants have these qualifications. If you don't have them, talk to us about what qualifications you have got. And sometimes we can make allowances if you've had a really tough time of it. But it has to be said that the students with these predictions will tend to have a far greater chance of getting a place. Okay. But as with anything, let us know if you're not predicted and we can look at that. And you can find the specific requirements for other qualifications aside from A levels and IB at our website, undergraduatestudy.cam.ac.uk. So generally, we are looking for students who are doing maths and 2 sciences, so chemistry, biology, physics are the norm. And if you are able to do further maths, again, biology, maths, further maths, is becoming increasingly common for biologists. By far the most common combination is biology, maths, and chemistry. Occasionally we have students who have 4, and as I'm sure I'll be asked later on in the questionnaire, if you are doing 4, that's great, it's good, but we can't give too much benefit to you having done a 4th A level because not everyone can do them. So we have to be fair in that sense. So it's great if you can do them because it gives you more prep. But in terms of qualifications, doing 3 A levels is absolutely the norm, and that's we offer to loads of people with 3, and some people with 4. But so we have to take a balance across these subjects. So a big part of my job is looking, yes, at those qualifications, but also looking at the entire application as well. And we take a holistic approach at Cambridge. So we look at all of the different parts of your application to come to a decision. And it's a long process. So from basically October through to January or February, it's an all-consuming process. What you can guarantee is that as an admissions tutor, we will look at your applications in their entirety. So we look at your academic record, how you've done to date. We look at your personal statement to judge your interest and your motivation to study. And in that, you can tell us, what you've done in the past. It shows us that you love biology or chemistry or physics, depending on what you're applying for. And we do look at your teacher's reference as well. So if the teacher tells us you're one of the best students in the class or the school or that they've ever taught, then that's great. Impress your teacher because they can often give us an indication of how well you're doing. We also look at your performance in the admissions assessment, the ESAT as well. So this is the assessment you have to sit specifically to apply to natural sciences. And it's a tough assessment. And I'll say later, you don't have to get 90, 100% to be invited. That's not the type of assessment it is. But we also look at context. So we're looking for the best students from whatever background they come from. And so, if you're the best student, if you're doing well for your school, that's great. And we look at all of that information. So we have information about how your school does in terms of A levels, in terms of the progression from your school to Cambridge. And we can use that to see how good you are in comparison to your peers. And of course, the interview is important as well, but it's not the final hurdle. We look at the interviews alongside everything else in the application. And it's just really important to remember that no part of an application is considered in isolation. I have never looked at one of these things on their own and just made a judgment on that. At every point, I'm looking at all of these things together to make a decision about who to let on to the biology course. Okay. So that's really important. What it does mean is you can do really well at one bit and not so well at another bit, and you might still get a place, or it could be the other way around, depending on the different things you do. So we're looking at things in a holistic way. Okay. You might ask, why do we do all of this? It's because we get really, really strong applicants. Sorry, my phone's ringing in the background. We want to choose between great applicants and for our really competitive courses. And so interviews, admissions assessments, aptitude tests, and work help us assess the suitability of an applicant for a chosen course. So we're looking really to see your potential on the course and how well you're doing. We're really looking for potential as opposed, and if you're on a trajectory upwards, then that's a great thing. Okay. So just on that note, why do we do assessments and interviews? So the ESAT is just worth talking about briefly. It's a multiple choice test. And it's, as of last year, it changed slightly compared to previous years because we had a new provider. And basically, you have a 40-minute multiple choice question on maths, multiple choice section on maths, and then you choose 2 sections from biology, chemistry, physics, or maths, each of which is 40 minutes each. And so overall, it's a 2-hour test divided into 3 sections, and you have a degree of choice. Most applicants for biological and natural sciences will do maths, biology, and chemistry, but you can do other subjects. You can choose other subjects from those if you wish. Okay. So just to give you an idea of some of the types of questions that are on the ESAT, but bear in mind you can have a look at past papers and you can have a look at sample papers as well for the ESAT. If you go to the Pearson VUE website, you can actually have a look at questions. You can even go through some past paper or some papers to see how you might do under time conditions. But the maths ones are quite general questions. You can see one based on admissions charges and working out sort of a little bit of algebra there. The ones based on biology, chemistry, they're quite tough because they're not just a 4-answer multiple choice question. They require you to look at a number of bits of information and you have to choose a combination of answers. So you can see here that in this question in particular, there are 8 possible answers. But you need to choose a combination of the different answers in that sense to get the answer. So they are quite tough. But it's worth bearing in mind that for these assessments, if you're performing above average, then that's great. And there's a good chance that you'll be invited to interview if you're performing above average. Homerton, we do use these in deselection partly alongside other applications, but we try to interview most students. And if you're performing in the bottom sort of 20%, that's probably the area where you might be in a slight bit of danger of not getting an interview. But for us, if you're performing at above average, then there's a good chance. I can't promise it, but there's a good chance that we will be able to invite you to interview. Okay. And the average score is about 50%. It's not a 90% performance test. They are tough. Okay, the best thing to do prepare for these is to go online and to practice what's online. You can even have a look at past papers as well that before this new version, because the structure of the questions is basically the same, even if the structure of the exam has changed or the test has changed. So don't be afraid to look at the questions from before the new version, because many of the questions will be of a similar format. Okay. Now, finally, and this is the interesting part of this presentation, I want to take you through the interviews, and in particular, the types of things that we look for in interviews. Now, interviews are great because they give us another way to assess students that goes beyond just seeing if they know stuff. And there are loads of different ways of thinking that we can look at when we interview students. This diagram in front of you is something called Bloom's taxonomy, which basically identifies a kind of hierarchy of thinking skills. Now, at interview, we expect that you have knowledge down the bottom here. That's, we expect that, particularly of GCSE level stuff, but maybe some early A level material. What we'll often do is check whether you fully understand what you've been taught. So some of our questions will be focused on probing to truly see if you understand what you've been taught. And part of that often involves looking at how you can apply your knowledge to new problems. Because if you do understand information, you can often apply it to a brand new problem. So many interview questions will be questions you won't have heard before, but which ask you to apply what you know in a new scenario. And that will enable us to test whether you truly understand what you've been taught. Okay. It will also, many interview questions also involve analysis. So very frequently in the sciences, we'll give you a graph or an equation or an object to have a look at, which we ask you to think about using your knowledge and understanding. Again, you might not have encountered it before, but you will be able to get to an answer if you know and understand your course materials well. And finally, if we really manage to push you, the top two tiers of the triangle are synthesis and evaluation. Very often in interviews, we'll give you bits of information that will ask you to piece together in a structured, sensible way to come to an answer. So you should try to listen throughout the interview. And often the things that you're talking about, you may need to use later on to piece together an answer. So all of these skills that we're looking for, we can do in an interview. And it's worth remembering that we as interviewers can give you hints, we can give you guidance, we can point you in the right direction. We're trying to see how you use information. And as part of that, we'll constantly be talking to you, giving you, bits of information for you to listen to and assimilate. So one of the key skills that we look for in interviews is listening and using what we tell you. We don't expect to ask a question and then you to just roll off the answer, tell us everything you know, kind of like verbally just regurgitate everything. That's not what we can often, that's not what we generally look for. We're looking for how you listen and use information. Okay. So these questions are going to be challenging. They'll need new approaches to using the knowledge that you have. The interviewers will prompt you and guide you. And very often they'll be focused on the work you've done at GCSE and early level already. But also remember, we'll be giving you prompts, things you might not have seen before to guide you in your thinking. And it's worth remembering these aren't trick questions. We're trying to see how you put together information. So we've got no hidden agenda. We're trying to see your underlying sort of thinking skills. And it's worth remembering that these kind of skills are really important in the supervision system that we have at Cambridge. You'll be asked to do these kind of thinking approaches and to discuss things and we'll push you in supervisions. So these interviews also give us a good insight into how you'll thrive in our supervision system. Okay. Just a few kind of key facts here. Interviews normally last 20 to 45 minutes. At Homerton, we do generally 20 to 25-minute interviews, so about 15 minutes overall. And each of those interviews has 2 interviewers, so you'll be interviewed by 4 people overall. Okay. And each of those interviewers will give you a different question on a different type of biology or chemistry sometimes. They're all problem solving. Currently, most colleges are interviewing online, and I can tell you that for natural sciences in biology, we will be interviewing online for this year. I can't tell you anything more about what we're going to be doing in future years because there's a lot of debate about that at the moment in the university. And remember, they're an interactive assessment of how you use information. Okay. Now, let's go through a few questions. Sabrina, I don't know if you're still there, but I'm going to whip through some interview questions, probably for about the next 15 minutes or so. The first one is actually an engineering question, but I just like to sort of demonstrate it because it tells you the kind of structured thinking that we look for. So the question is, how many squares are on a chessboard? How many squares are on a chessboard? Does anyone know the answer? You can put it in the Q&A. How many squares are on a chessboard? One of my favorite questions ever. It's actually from engineering, but it tells you the type of thinking skills we look for. Anyone got any ideas? Now, how many squares are on a chessboard? Someone said 64. Good answer. Now, that's the most common answer. And you would have calculated that by 8 times 8. That's good. And if I tell you that's the number of 1 by 1 squares, and suddenly everyone is thinking, oh no, that means I need to calculate the number of 2 by 2 squares, the number of 3 by 3 squares, the number of 4 by 4 squares. Now, what we'd be looking for in that is for you to take a systematic approach. And if you think about it, if you think about how many 2 by 2 squares there are along the top of a chessboard, there are 7 2 by 2 squares. You can actually think about it by the center of each 2 by 2 being, like one of the points in the middle. So there are 7 along the top, 7 down. So the number of 2 by 2 squares is 49. Then, of course, I ask you about how many 3 by 3 squares there are, and by logic, you would hopefully get to the point that there are 6 by 6. Number of 4 by 4 squares is 5 by 5. So basically, it all distills down to the sum of the squares between 1 and 8, which is 204. But the calculation at the end is the least important part. I'm looking for you to take a systematic approach. Someone says 204. Well done. And someone got the equation. Brilliant. So what we're looking for you to do is to take a systematic approach through these questions, and use a structured logic, but also that requires a little bit of lateral insight as you progress. Okay. Let's move on to another question. Now, this is a question from I think from about 3 or 4 years ago. This is my question from then. And it's a graphical interpretation. So I presented students with this graph. And I first of all asked them to tell me what they think it shows. Okay, so it's a graph of body weight versus brain weight. Okay. So that's fine. So it shows you the relative investment of body weight versus brain weight for a variety of animals. Now, I would ask, does anyone know what all of these animals are on this graph? Now, this isn't that important, but it's interesting to know if people do have an understanding of what types of animal these are. Does anyone know? Can anyone tell me what type of animals they are? They are all mammals, absolutely. They are all mammals. Good. So these are all mammals. Now, the next question would be, what do you think that tells us, this investment, this relative investment in brain weight versus body weight? What might that be an indication of? So at this point, we're still discussing things. What could it be an indication of? No one's answered yet. Oh, sorry, I've just gone too far. Now, the answer I'm looking for is, it shows that the animal is investing a lot in its brain compared to its body. So it must be using its brain something. And a natural step would be to talk about intelligence at that point. Now, if you said that, I would then say, well, what do you think intelligence is? And we would then have a discussion about the different modes of intelligence that there might be. But certainly the animals above this kind of this average line here are all viewed as being quite clever. The dolphin, the man, the chimp, the monkey. We won't talk about this one yet, but to a certain degree, the mouse. It's all an indication that somehow their brain is being used for something. And I'd use that as a point to discuss the concept of intelligence, which is really broad. There are loads of different modalities to it. It's quite controversial, but we'd talk about it briefly. Okay. Then I'd ask, what does it mean if an animal is above this line that runs through the center of all these mammals. And that would mean that the animal is so this line here is basically the kind of the line of best fit to all of these points. So it means that compared to other mammals, it is investing an above average amount of its mass to its brain. So I want you to interpret that graph based upon literally mathematically what it is. At that point, I'm really whipping through this so you can see all of the questions I would ask. This is a multi-phase question, by the way. At that point, I would ask, can you calculate for me the brain to body weight ratio of the rhesus monkey? The brain to body weight ratio of the rhesus monkey. At which point, students would look at the axes and go, "Oh no, that's a bit weird." What I'm looking for students to identify here is that this scale is a bit odd. It doesn't go up in equal numbers. And I would ask you why you think that is. And if you think about it, this is going up by 10,000 and this is going up by 10,000 times. So this is actually a logarithmic graph. And whereby each interval is a multiply, is a multiple of the previous one. It's being multiplied to get to the next value. So then I would sort of say, well, can you work out what this value is here? If you think about it, if it's all being multiplied, this value here will be 0.01 because it's between the two. So it's 100 times and then another 100 times. And this value here will be 100 because 1 to 100 is 100 times and then 100 to 10,000 is 100 times. So once you've worked out those points, you should be able to work out that this point here, again, if you take that logic, will be something about like 10 kilograms. And you will work out the rhesus monkey here. This axis is going up times 10 each time. So this will be about 100. And again, I would help you in this if you got stuck. Then, of course, I would ask you what the brain to body weight ratio is. And I would hope that you would pay attention to the scales. A lot of people don't. It's not a deal breaker. It's a common mistake. But if you would hopefully I realize that this is in kilograms and this is in grams. It's something important to identify that you would then talk about everything in grams. And you'd get to an answer. So a number of biology questions will have a mathematical element to them. You should be prepared for a little bit of maths. Sometimes, it may not be the most advanced maths, but most of the time we will check on a little bit of numeracy and number manipulation when you're doing your interview. I would say that the most common question that you'll be asked in interviews in terms of numbers is about scaling. You'd be amazed at how many students get questions wrong in terms of getting scales right. I mean, even sort of going from millimeters to micrometers or up to meters, there's, I often use it as a check just to see how you can manipulate numbers because it's an important part of the course. Finally, on this, I would ask you what you think this red animal is. And I would tell you that this animal, this dot here, is not a mammal. So I'm asking you to try and work out what you think this animal is. Can anyone tell me what they think it might be? Any ideas what an animal at that point in the graph should be? What do we think? It's not a mammal. Any ideas? An octopus? Yeah, there's probably about that side. Yeah, a lizard. Maybe not. So the logic behind the octopus I like is in that octopuses have quite big brains, and that's what you've identified there. It's got quite a big brain for its body. I tell you, it's not an octopus. It's actually another vertebrate. And someone says some type of bird, and that's right. Songbirds actually have quite big brains for their body. That's true. This isn't a songbird. It's another type of bird, and someone has got it down the bottom here. Some of the most intelligent birds are the corvids or the crows. And so this actually is a scrub jay, an animal that's been extensively studied at Cambridge for its incredible abilities in memorization. And then if we had time, I would then start talking about how you would test the intelligence and the memory of a bird. So we would go into a kind of discussion about how you would do this. This is all in about 10 to 15 minutes. So I've gone faster through it. But you can see that during the process of this one question out of 4, we're actually touching upon lots of different aspects of biology. You may not know this graph, but the things we're asking are asking you to apply what you know in all of these different scenarios. Okay, so that is a question from a few years ago. Let's move on. So this is actually my question from last year. So you're getting an update. So this is my interview question from last year, and it's based upon a graph again. And once again, I've this time I've got a geological timescale, and I've got number of species up the other axis, and I've got 3 lines, and each of these images represents a different type of plant. Just as a bit of interest as well, again, a kind of starter, I'd say, what kind of plants do you think these represent? And if you might recognize that this is a fern, and this is a flowering plant, and that this represents a conifer, or a gymnosperm, as we sometimes call them. But again, that's just a bit of that's not the most important thing. So what I will then ask you to do is explain what this graph is showing. And hopefully it can show you'll be able to explain that it shows you that in all of these different groups of plant, the number of species is increasing across geological time from 300 million years ago up until present. And you can see, I might ask you then, how many species has the number of ferns increased by between 300,000 years ago and 50,000 years ago? So again, I'd ask you to look at the scale. Again, last year, I went back to the kind of logarithmic thing, but also in this case, I was looking you to think about tens of thousands of years, and to really look at the axis. So I would ask you, to do a little calculation there. Then we would start talking about this green line, which represent the flowering plants, and I'd ask you to sort of talk about what that trend shows. And what you can clearly see is that the flowering plants, the angiosperms, have increased dramatically in diversity since 150 million years ago. And I'll ask you to sort of explain that kind of increase and why that happened. And then we would move on to a second question relating to this that relates to angiosperm diversity. And I would show you this picture. And these are 3 species of the same family of plant. And below them are animals. And I would ask you to tell me about the relationships that occur between these animals and plants. Now, hopefully, you'll have an idea that, bees, for instance, have a role in pollination. But, the key thing I'm looking for is for you to be able to explain how an insect might interact with a plant. Now, you might talk about predation, that's fine. You might talk about various other things, but I'm predominantly looking for you to talk about pollination. And I'll then ask you to think about which features of the flowers actually are connected to the features of the animals. So, for instance, of course, this is all in the context of plants wanting to attract pollinators to disperse their pollen. And moths are night flying, so color isn't particularly useful for moths, and so that explains why you might have white flowers. Bees are very good at seeing in the UV, and they need quite sturdy flowers. And animals like hummingbirds, they have really deep, really long beaks, and actually this flower on the right-hand side is deeper. And also birds are very good at seeing red. So I'm basically looking for you to sort of make associations between the flowers and the pollinators. And then here's the big question. I would ask why that relationship explains the diversification in part of the angiosperms. This is the big question. So I'm leading up to this. I'm showing you how the angiosperms have increased in diversity. I'm talking about animals that are related to the angiosperms in terms of pollination. But the big question is why there are so many species of flowering plant? Yeah. And the basic answer to this one, and it was gained very rarely actually, is that the number of species is a result of the diversification of both the flowering plants and the pollinators. Because what a flowering plant wants is to attract a pollinator that will transfer its pollen from itself to the same species. Okay, so it wants a specific pollinator to come to it. So it will develop adaptations to attract a particular type of pollinator or a group of animals that will tend to take its pollen to the same species more frequently than it will take the pollen to a different species. It doesn't want its pollen going to completely different species because often that will fail. So what happens is the flowers develop these adaptations to attract a pollinator, and in turn, the pollinators develop adaptations to gain the pollen or the nectar of the flower to which they're attracted. So this sets in cycle an evolutionary arms race where the flower is adapting to attract the pollinator is adapting to gain the pollen and nectar more effectively. And what that does is it tends to lead to this evolutionary arms race that leads to a very rapid evolution, but also a diversification of the flowering plants as they adapt to their pollinators. So both things are evolving, which leads to very fast evolution. But because flowers want to attract a specific pollinator, that leads to this incredible adaptive radiation, as each of the flowering plants basically can attract a different pollinator. And more pollinators evolve as they become attracted to different flowering plants. So we're sort of building, hopefully you can see that in this question, we are building upon bits of information and then I'm asking you to synthesize it late in the question. Hopefully that makes sense. You can see the logic here. I'm giving you information, asking you to talk about it, but also looking at how you put information together. Now, that's my interview style, and many of my colleagues do a very similar thing. But generally speaking, in interviews, this is what we can do. We can see how you can take on board information, put it together. It's not something that's easy to prepare for, I'll be honest with you, because you won't necessarily you won't be able to predict what question you're going to get. I'm not going to be asking this question this year. I can tell you that for a start. It will be on something completely different. But you can see the things that we're looking for. Okay? Hopefully that makes sense. And we can test a very different type of thinking skill than we can do in some of the assessments. Remember, though, we'll be helping at all points. We'll be giving you guidance, and we're, to get you to the right point. To prepare for interviews, basically, the best thing you can possibly do is practice listening to the interviewer. You can also practice talking out loud so that the interviewer can see what you're thinking or hear what you're thinking and be able to give you better guidance. But also, you just really practice talking to your friends, about science, because a good interview is one that's two-way and actually is often very enjoyable. Okay. Just as a final one, if we did get to through that question, I've then got another mathematical question that I would be asking. This is quite a tough one. I'm not going to tell you the answer. So a bee visits flower A for 80% of its time. A bee visits flower B for 20% of its time. The bee can only pollinate the same flower type. And then what proportion of the pollinated flowers will be white? It's a tough one. It's actually quite a tough question. It's harder than you might think. But again, I would give you guidance through that. It's also worth noting in interviews that you'll never get through an interview completely. Like an interviewer will never say, "Oh, I've finished all my questions, so we're finishing the interview." We will keep on asking you questions as long as we have time. And that will mean that at some point in the interviewer will say, "Okay, we've run out of time." That's not bad. That doesn't mean you failed. It's something we say in every interview when we have literally run out of time, because we could continue asking questions for the entire duration of however long we've got. So don't panic if we say you've run out of time. Okay? Good. I'm afraid I won't have time to go through it. The question here was, how can you have so much diversity in these snails given what you know about natural selection? And there'd be lots of questions about genetic crosses, about you've done about Mendelian crosses. We would talk about what natural selection is. We'd talk a little about sexual selection. We'd talk about predation. And we'd go through lots of different aspects. But again, it's a multi-aspect question to test your general thinking skills. Just remember that to get through interviews, they hopefully they won't be. Hopefully you'll see that I'm not that scary. It can be a lot of fun that if we're in interviews, and sometimes students really enjoyed them. The best thing you can do is just be organized, just be willing to answer questions. You don't have to be enthusiastic even, but we want you to answer questions out loud. Tell us what you're thinking, and then we can help guide you. And in particular, if you get it wrong, that's absolutely fine. We will give you some hints. And if you then take on board those hints and then get it right, that's a really good sign, you know. And it's okay to get things wrong. Every single interview I've ever done, someone has got something wrong, at least one thing wrong. But the best interviews are the ones where they've got it wrong and I've given them help and they then take on board that information and get it right. Because it shows me that that student can take on board new information. They're not fixed in their ways of thinking. It's not just about what they know, it's about what they understand and how they can bring in new ideas. Okay. And just as a summary, what do we look for? Just remember, we look for an interest in your subject. That's really important, the most important thing. We want you to proceed, but in potential to succeed, but in particular, we want to see your potential. And if you're on an upward trajectory, that's great. You've got to do okay in exams. You know, we know that if you've had difficulties, we can take that into account, but we are looking for a strong record in examinations. We're looking for a good reference. In that natural sciences, vocational commitment is not as important because you could go in all sorts of different directions, but you know, we're looking for an interest in biology. Okay, so to prepare, just make sure you've got the right course. Make sure you've read around to make sure that this is the right course for you. Explore your favorite subjects more widely and keep on working hard. Try and get as high grades as you can at every stage. But remember, we do realize that some students have particularly difficult times at school. Make sure you're doing the right subjects to apply for somewhere like Cambridge. If you're still deciding on subjects, remember that we look for sciences and maths. And just make sure that we're the right university for you. And it may not be for everyone. It may be the right university that your parents want you to go to, but if we haven't got the course for you, then it may be perfectly, it's okay to say that actually this course does the thing I want to study and I want to go there instead. You know, it's a difficult discussion to have with your parents, but our course isn't for everyone, but it is a great course and full of amazing stuff to learn. It's tough, but it's rewarding. And at the end of it, many of our students go straight into research. Okay. So that was a very, very quick whistle-stop tour of natural sciences and interviews. I'm joined by Neve. Hey, one of my own students now. Thank you for joining us. Can you hear us? Can you hear me?
Yes, I can.
Yeah. Okay. Do you want to tell everyone a little bit about yourself and about what you're studying now and what you think of the natural sciences course, and then we'll move to some Q&As later on.
Yeah. So hi, I'm Neve. I'm in my final year now, so I'm coming up to exams in biological natural sciences. And I've specialized in pathology, so the study of disease. That's the area that I've specialized into in my third year. In first year, I did all of the biology combinations I could. So I did evolution of behavior, biology of cells, physiology of organisms, and then mathematical biology. And then in second year, I did pharmacology, cell and developmental biology, and the biology of disease. So yeah, and even with just completely doing biology courses and modules even, you have such a diverse repertoire of information at the end. So like I'm still able to use information I learned in my first year just from doing various other combinations in my final year now, having specialized. So yeah, I think that would definitely be probably my favorite thing about the degree. It's just how varied it is. And like the course is very much designed to sort of teach you those research skills. So like lateral thinking and just really about just being able to discuss information as Paul was talking about with interview preparation. It is really just about developing those key skills. And that means that no matter what information you interact with, you'll still be able to come up with ideas and laterally think and connect things together. And definitely now looking back through my degree, that is 100% what everything has been doing at each stage. And it's just really enjoyable, and the opportunity to engage one-on-one and like in small groups and supervisions and stuff like that with people who are sometimes experts in the field is just really rewarding. And there's nothing that like emphasizes and drives your enthusiasm more than being in an environment where everyone else also loves what they do. And it really does just push you to really be even more passionate and pursue what you love. So yeah.
That's great. Thanks. So what's been your favorite part of the course overall? I mean, the
Um,
best activity that you've done, the best thing you'd say about the course.
I'd say the supervisions are my like complete favorite aspect of the course. I think for preparing for research and any future career and whatever, practical skills are also amazing. Like the practical experiences that you get through all area, like starting from first year, even a really, really crucial and really, really good experience, especially when you go into like making applications for internships and master's courses and like future planning, like it's pretty unparalleled practical experience. But I say the supervisions are definitely the most enjoyable part for me. So just being able to discuss information that's sometimes at like the forefront of the field, like completely new ideas in an academic setting with someone, and it's so yeah, intellectually stimulating and rewarding. And it is definitely a culture that really does reward passion and enthusiasm. And that's just lovely. I really enjoy it.
Thank you, Nick. So we're going to go to some questions now. So I'll go through a couple, the ones about admissions, and then we'll come back to Neve. So the first one is, does choosing a college affect how likely you are to receive an offer? Now, there are differential numbers of applications for each college and different numbers of places in each college. So if you apply to a college which has lots of applications and few places, then you're less likely to get an offer at that college. But we have a backup system, which means called the intercollegiate pool, which means if you apply to a college with loads of applicants and you don't get a place, but they think you're good, they'll put into this pool and other colleges can take you. And a significant number of biologists actually get taken from the intercollegiate pool each year. I mean, it was sort of over 150, I think, last year, or maybe about 100. It was quite a lot. So that asymmetry in applications can sometimes is managed by this intercollegiate pool. Someone asked, what written work would we need to submit? For most colleges, you don't need to submit written work because the admissions assessment is really important. Someone asked, is it beneficial to mention Cambridge in your personal statement? If you're overseas and you don't apply to other universities, if you're not applying to any other universities, there's no harm in doing it. But of course, you don't want to put about Cambridge into a statement if you're applying to another university. You don't want to be applying to sort of, Warwick and say, oh, Cambridge is the best university ever. But yeah, if you're not applying to anywhere else, then it doesn't matter. To be honest, actually, because if you do put in an open application and it's sent to another college, most colleges, colleges don't know that you've put in an open application for the most part, because your application is funneled into the rest of their direct applicants. And actually, for the most part, I can't tell. And it should make no difference at all to whether you to a decision on you. Someone asked how biological maths differs from regular maths. Maybe give you that one. So if you say what's in it, mathematical biology, yeah.
Mathematical biology is much more about like statistics that you'd be able to use in interpreting biological data. So like working with like sample sizes and that sort of statistics as well. But also you do like epidemiological modeling with like differential equations. That's really interesting. And also about like trying to predict animal behavior based on optimal behaviors and that like with matrices. So it gives you a good foundation in maths, a very good foundation in maths, building on stuff that you would have done at A level, but then it puts it and frames it in a more biological context. So like it is still quite mathematically vigorous, at least it was for me, but it's much more in the context of biological systems and like population dynamics and stuff like that as well.
Good, thank you. So someone asked, do you have scholarships to cover the tuition of EU and to cover the EU students, basically? There are some some monies available from the Cambridge trusts that cover, and you can have a look, if you look at Cambridge trusts for some scholarships, though that's a centralized university body. But unfortunately, we don't have scholarships for obviously everyone that applies. It's quite a competitive process. I'll be honest, it would have been great if we could have stayed in the EU and had we saw our numbers of EU applicants drop, which was tragic. We wish we could, but unfortunately, we have the overseas fees, and there are some grants. So it's just worth looking at those online. Some of them are partial, but it is difficult. I know. I'm so sorry that we left the EU. You never know. We might be back at some point. Someone asked, what supercurriculars would you advise for someone wanting to study biology at uni? So anything that demonstrates your passion for biology. I mean, for instance, you may have encountered the Cambridge Biology Challenge, where every couple of months we set you a biology question to work on in teams. That's a great thing to put. Or biology Olympiads, or just participating in anything biology related. We know that everyone has a difference in terms of experience, but anything you could do. I don't know if you could advise anything, Neve, on that one.
Yeah, I think, well, like when you're talking about extracurriculars and stuff like that, if there's any like online courses as well that you've done in biology, that might be quite good. So because you can do some really good genetic engineering or like paleontology courses as well, just to show like extracurricular activities. But also, yeah, I mean, the main thing that I hear people talk about, and I did as well, was like additional books, and then like how that started your interest, like reading, and then just showing how you take that further. Like once something's interested you or a concept, and then how you pursue that further through like online lectures or various other outlets. Just about like enthusiasm, as Paul was saying.
Yeah. Okay. Someone asks if they want to focus on chemistry and they want to do cells, materials science, and chemistry in the first year, should I apply for the biological or physical natural sciences stream? To be honest, this is always one of those borderline ones, because you're with materials, cells, and chemistry. That is really at the borderline, because it's one biological subject, one physical subject that we class material science and chemistry. I think the key thing is probably a lot of it will depend on what maths you want to do, I think, because that would slightly tip the balance slightly towards one. To be honest, we've had applications down both routes with those subjects. I guess what I would advise is choose the kind of, think about it in terms of where you'd excel most, in terms of the whether you'd excel in biology and chemistry interviews, or excel in like more physics and maths interviews, and which parts of the ESAT you might want to do, which you might excel at. Think of it in that way to give yourself the best chance. Because at the end of the day, once you arrive, we can't stop you changing subjects. So it's between modules. So play to your own strengths and think about what type of interviews you might get. I'd say. I think that's a fair way to put it. Someone else, if they open apply and they don't have A-level chemistry, will they be sent to colleges that don't require chemistry? That should happen, yes. Yeah. If it's sent wrongly, it should go to another college afterwards. Advice for ESAT preparation: practice, 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 and blind practice. So look at the questions, go through the practice exam papers, which are online in the online delivery platform. Go through them online, do the tests, then go back and work out which ones you got wrong and work out why they were wrong. Don't go through looking at your notes. Go through and do them as a test, because that will give you an idea of the timings that it takes. It'll give you an idea of what you need to revise and prepare. But practice, practice, practice. And a big secret: you can go back to the pre-2024 test to get some ideas of the types of questions, because the question types are similar, if not identical, but there is a lot more material from the pre-2024 questions, but it's basically the same types of questions, even if they're done in a slightly different way and in a different format. So practice, practice. And what was the last thing? Oh yeah, practice. Will a low ESAT score largely affect an application? Now, remember, it is tough. We do know that there are, differences. As I mentioned, if it's very low, if it's in the bottom quartile or quintile, bottom 25 or 20%, it may affect your chance of an interview. I won't lie to you, because that's one of the primary reasons for it. But we do look at the other parts of the application alongside that as well. Yeah. Someone says, do they know where I could practice for questions such as these to develop my thinking skills? It's a difficult one, because it is I spend a lot of time doing doing interviews. It's difficult because the very nature of the question is a kind of narrative where we talk you through and we sort of talk about what we're looking for. And I'll have to think about how we might give people more experience of that. That's a difficult one. I'm stuck on that one. So yeah. But remember, it's difficult to prepare. It's more about how you think rather than preparing for a specific question. Someone asked, so Niv, did you know what you wanted to specialize in before, or has it changed over time?
It has quite dramatically changed over time. Yeah, I mean, before going to university, I was interested in immunology, but also in animal behavior. And that was like the two areas that I was really interested in more so. But then when I came to university, I think because of the way the course is split as well, is like it kind of you tend to go more into the like in second year and third years, you kind of have to specialize a bit more. So I had to stop doing zoology, but that's only because I picked to do pharmacology, so I didn't have to. It was a very sad decision I made, and I think about how different it would have been
I was
sometimes.
gutted. I was absolutely gutted because I wanted to do zoology. So yeah, but there we go. Yeah.
It was my
Anyway,
favorite module by far in first year. But yeah, as there's so much opportunity to change direction and to do new things. Like I thought I knew exactly what I wanted to do going in, and it's completely changed multiple times. Like it's very much each year you do what you enjoy most, and there's so much opportunity for flexibility that I wouldn't worry too much about having like a complete sorted out idea, because it will definitely change, would be what I would say.
cool. Thank you. And another one, what do you find interesting about pathology?
Oh, most things. Specifically in the context of like therapeutic intervention, I think would be the area I'm the most interested in. But I really, really love trying to understand this, like the systems that enable us to then down the line make pharmacological interventions. And also just like what Paul mentioned as well in the interview, how pathogens have co-evolved with people is just amazing. Like conceptually, like, as soon as you add an evolutionary perspective to something like disease and infection, it's just amazing, because it is just everything has evolved to be the way it is, and and seeing how all the cells in the immune system interact, it is amazing. It's hard not to love it, in my opinion.
Good stuff. Another one for you. So how important would you say work experience was for the natural sciences course?
I mean, in getting in, I didn't have any work experience. I just had like independent research that I'd done myself. I don't know if that classifies as, I don't think that's work experience, but work experience during the course, like in terms of like internships, is very useful, like when you're applying after the degree. But also the course itself, I don't know if I'm answering the question right, but yeah, I mean, the course very much sets you up with practical experience to then go on and apply for internships and masters and whatever you might want to do in the future. But work experience did help me so I had a short bout of work experience at a hospital in a microbiology lab. That was really useful experience going in for my second year, because then we repeated some of the experiments and you kind of understand the biology behind how the hospital works. And then also then applying to internships, having that degree of practical experience paired with the actual ones I'd done in lectures and stuff was really useful. Do like clarify if that didn't answer your question, because I don't know if that really did.
I mean, I see everything. So some students have loads of work experience, others don't. We know that not everyone has the same access to work experience. So I'm from a state school, and I wanted to get work experience working with animals, and I got given an internship in Debenhams. So yeah, in a clothes shop. So not everyone has that opportunity. So we do take into account that as well. But anything that motivates you and drives you to think about the course in more detail is good. And I'm going to give you another one, Nick, because I'm going to go through a chain of the admissions ones. But another one is, what did you find most difficult about starting the course?
I think the course is very difficult if you go into it as like a person. If you view it as you're just one person doing the course, it's very difficult. I think as soon as the thing that definitely made it a lot more manageable and less intimidating and less imposter syndrome was just working with a group and teamwork. And that's definitely something that is very much like recommended and advised. And it is like facilitated through the way that some practicals are and lectures and stuff. Just not basically viewing yourself in isolation and acknowledging the fact that all of the things that you're feeling about imposter syndrome is the exact same as everyone else. In terms of content, though, I think the maths was definitely the biggest step up for me personally, but that's because I hadn't done maths to the same degree that other people had. So you feel like that going into it, but I got so much additional support with that from the college as well. So that I felt a lot more confident with that then.
I mean, we really do encourage students to work together at Homerton. It's a
Oh,
big
yeah.
thing. I say it in the first year. You know, you're not competing against each other. You're not,
Mm.
you know, and it's not necessarily the same across the board. But I want you to do as well as you can do. And all evidence says that when students work together, when they become a team,
Mm.
they go far further than if they're just sitting on their own in their. You know, I'm not saying you can't do that, go work on your own, but just having the ability to bounce off ideas off each other is so important.
Mm.
Another one related to, and again, Nick, I'll let you one last one. They say, aside from research or postgrad study, what kind of career options are common after biological natural sciences?
I know a lot of people go into consulting. I have quite a lot of friends that's the like graduate schemes that they've applied for in that can be general like life sciences consulting, but also I know a lot of people that are going into more finance jobs. And that's sort of it's I feel like just because of how transferable the skills are that you get with data analysis, competency at like writing essays and being able to like have a dialogue, but also then mathematical skills, it does really set up with a wide variety of but I mean analytical skill set, that's as well what we get taught. But yeah, so it is quite varied. But I mean consulting and I want to go into research, so I'm quite biased towards that. But I know a lot of other people are much more interested in data analysis roles as well as finance and stuff.
Thank you, Nick. Right, in the last few minutes, I'm going to whip through all of the remaining questions. So I'm not going to be able to answer any ones that haven't been asked already. So student asks, if my school doesn't offer further maths and I want to apply for physical natural sciences at Cambridge, will I be at a disadvantage? If your school doesn't offer it, that's fine. But if it does offer it, we do expect you to take further maths because it is a useful and it will just require you to do quite a lot of catch up. We'll advise that you study the further maths syllabus before you start, even if you're not doing the exam, just to make sure that you're as prepared as possible. If you study both maths and further maths, which one of these will your offer be based on? Well, it depends if you're doing 4, but you know, normally at Homerton, we class maths as one of the A levels. So it might be maths, further maths, and physics, which is that's quite a common combination. If you want to take physics and biology modules, would you take biological maths or maths? Well, it depends what you want to do afterwards. So we advise that if anyone wants to do chemistry and wants to do physical chemistry, doing the physical maths is important. But it's perfectly fine doing biological maths if you're going to do biochemistry. Okay. Would interview questions be based around topics that you've written about in your personal statement, or are they more general topics? Generally speaking, and it does vary a little bit. Sometimes we do touch upon your personal statements just as a kind of starter question to see if you understand what you've written about. But most of the time, we'll have questions pre-prepared, a range of questions pre-prepared, so that so that we can test you on new material. Okay. Someone else, do you need to mention Cambridge in your personal statement? You know, it shouldn't make a difference if you're mentioning it or not. Just as long as we can see that you understand what our course offers, that's the key thing. That you're suited for the course. You can mention it if you're only applying to us, that's fine. Someone and you also ask if they have higher grades than average. Does that make a difference? Well, the higher the grade you get, you know, it gives you a little boost. But almost everyone that applies to us will have the grades or higher predicted grades than our offer. So yes, it can make a difference, but we're looking for, and it can show us some of your potential, but we're looking for potential elsewhere as well. So yeah, all of these little things can add to it. Someone says, is the Cambridge Chemistry challenge, good. So I'm talking about the Cambridge Biology Challenge, which I run. So if you type in Cambridge Biology Challenge, it's run by Homerton, and you'll see some of the silly videos that I've made introducing different questions every couple of months that you can answer as part of your school. You can make a group, work as a team to answer these quite amazing questions, like, why don't animals have wheels? Why do animals dream? I think one was like discuss something seasonal, discuss something weird through a biological perspective. There's all sorts of different questions, and we'll be starting the new competition in New Year's. Someone says, I want to specialize in neuroscience and psychology. Should I write about that in my personal statement or keep it broadly about natural sciences? Well, we know that you're applying to other universities, so we quite often see students saying they want to specialize something in something. That's fine. It's normal. It's not going to make a difference. Can EU students attempt the biology challenge? Well, we just think we at the moment we're working out the new version. We finished the last one at the moment, so look at our channel, and we'll work out how we're going to do it for next year in the next couple of months. What was the average ESAT score for natural sciences? It varies, but most students it's about 50%. When should you start revising for ESAT? Now that's an interesting one. ESAT, the questions are based largely on GCSE and early A-level knowledge, so it should be part of your revision anyway. So just make sure you're familiar with what you're being taught on the course. Now, if your predictors are below requirements, but you do well in the final exams, could you still get in? Well, we kind of need to see that you can get the grade. So speak to your teachers if you're predicted lower and just see why that is, and see if you can, see why that is, because we will need you to get the A star, A to be eventually. So we'll want to see that you're predicted that. Sorry, I'm motoring through here now. If you're applying down a biological route without biology A-level, is that a disadvantage for interview questions? We do have that occasionally, normally what we do at my college, and we do try to align interview questions so we'll know that you haven't done it. So you will have done GCSE or equivalent, so we'll focus on the base level material there, but we'll still push you to try and apply that knowledge. But we'll make a note of it, and we're not expecting you to know things that you haven't been taught. If you're not doing further maths for A-levels, can you still get in? For biology, it's quite common that people don't do further maths. For physics, it's rarer, and we advise you to do further maths if you can. Do different colleges have different interviewing styles, or do you will have a common bank of potential questions? We all have completely different questions. That's to say, we have the same broad style, and I'm actually involved in training some interviewers quite a lot, but we look for the same things, we look for the same skills. We will have different questions each year and sometimes each day, so there's no bank of potential questions. So often students go back to their schools, and the schools ask, oh, tell us about the questions. Ideally, normally they will not come up again, because otherwise it would be too easy for schools to prepare. To be honest though, we can tell if someone's heard the question before, because it's quite obvious. But we try to change questions, and there's certainly different questions between colleges. Yeah. And last one, are there any Homerton or Cambridge chemistry physics challenges? Are there any Homerton or other Cambridge chemistry? Well, so at the moment, we are only hosting the Cambridge Biology Challenge, but I think there are other challenges across the university. So if you just type those in, you should be able to find those. We just realized that no one was offering the Cambridge Biology Challenge, so we thought we'd do it. And at the moment, we actually have 5,000 students doing it. And we have a big awards ceremony at Homerton coming up later in the year. So someone says, if you're doing physics, biology, maths, and further maths at A-level, what modules would you take? We've seen it all. We could do it all. There's flexibility. Once you arrive, you're given a free rein. We'll advise you, and we'll get you to talk to the second years about what the mistakes they made were, so we'll get other years to talk to you about what modules you might want to take. But the primary thing, and it's a good point to finish on, the primary thing is when we're looking for you when we're interviewing, when we're thinking about who's going to come here, we want students to enjoy the course, because it's a tough course. There's lots to do. Neve will say it's tough. There's a lot of work. And to really get the most out of it, you need to love subjects you're studying. And it's vital that you choose the right subjects. So we will give you every opportunity to talk to past, to other students, to talk to us, to talk to everyone, even sometimes even departments, to try and work out what will suit you. So I can't recommend anything until I know what would suit you as a person. And that kind of reflects Cambridge's approach. Yes, you do a broad range of courses. Yes, you get more specialized by the end of it, but the degree that you take at Cambridge is fundamentally yours. And you will have so much choice, and you'll be able to do projects in departments. You'll be able to make a biology degree out of all of these pieces that is specialized to you. And even when you're thinking about internships, a director of studies will advise you on how to apply for internships, to maybe even try and create your own ones, to go to a lab and say, have you got jobs? So we can help you create that kind of bespoke degree that's specialized to you. And that's a special thing, I think. Would you agree with that, Neve? Yeah.
Yeah, completely.
Yeah.
That is the perfect way of describing my experience of the degree. Like, even very independent things, like you said, like internships and stuff like that, being able to have like a director of study that you can talk to and actually know how you would go about like designing new ones or just engaging is just, yeah, as well as references, of course. But yeah, it's a very unique experience. Like, I have a lot of friends that do other degrees that are biology, and I'm just, yeah, this is very, very good.
To be honest, I've only just thought about explaining it like that. So you're the first people I've ever explained it to like that. But actually, it sounds good when you say it like that. But it is true. That's what you do. It's a very bespoke experience.
Yeah.
And you get to, I know all of my students really well, and I can guide them, as much as I can. But also it's a case of, you can talk to your friend. You have all those other amazing people around you who are also loving the subject. That's one of the big advantages, the kind of people you meet, the things you learn from them, but also this, the diversity of choice that you have in the course. Okay. And one final question, because I'm going to have to go. My wife, I think, ran an hour ago, so slightly worried now. But basically, will you get a recording? This is being recorded, and so we will upload this in the next day or so. Okay. Can I just say at the moment, because we have overrun, but thank you so much, Neve, for joining us once again. Great student, and thank you all for joining us online. And I'm sorry for overrunning, and I'm sorry for those technical bits at the start. I hope you enjoyed it. I hope you found it useful. And if you have any questions, our admissions office is always on the end of an email, and if you email them, questions can eventually come through to the admissions tutors like myself, and we'll do whatever we can to help. Okay, brilliant stuff. Thank you all, and take care. Have a lovely evening. Okay, bye-bye, everyone, and we will wave, Neve, say bye.
Bye.
Okay, bye.